So if we want to convert between degrees and radians, we know that there are 180 degrees per pi, or 3.14 radians. That's 180 degrees, same thing as pi radians. Well, we can set up the proportion then, where we have some angle in degrees divided by some angle in radians. Since typically what we're looking for is some angle, let's use some algebra and rewrite this. Let's take this as theta in radians divided by pi equals theta in degrees divided by 180. So if you know what your angle is in degrees, you stick it in here, divide by 180, multiply by pi, that's how many radians you get. For example, let's convert 60 degrees to radians. Well, we know what that should be. If we look up here, 60 degrees should be pi over 3. Let's see how our equation does. So what I'm going to do is I'm going to take theta in radians equals 60 degrees, that's theta in degrees, divided by 180 times pi, because pi comes over to the top here. So this equals 60 divided by 180 is 1/3, so that's pi over 3. Same thing, what we expected. Okay, well, what if we convert 25 degrees to radians? Theta in radians equals 25 divided by 180 times pi. This equals 5/36 pi. We can also go in the other direction. So now we'll do algebra and we'll solve this equation up here in a different way. We'll go theta degrees equals theta radian times 180 over pi. So let's say our theta is pi over 3, so we know that should equal 60 degrees, right? Well, let's do the math. So theta in degrees equals pi over 3 times 180 over pi. We see here that the pi's cancel out. We get 180 over 3. This then equals just 60 degrees. Let's say theta equals 2 pi over 19, maybe. So that's in radians. Let's convert. Theta in degrees equals 2 pi over 19 times 180 over pi. This cancels. This cancels. We end up with 360 divided by 19, which is approximately 18.95 degrees. Okay, so what are some applications of using radians? Well, one thing that's easier to do with radians than degrees is figuring out the arc length on a circle. Okay, so suppose I have the center of the circle here, and we have radius of this circle, r, and we turn this thing enough so that we have exactly r here, or just some length, not necessarily r, but some length along the outer edge. That's going to create an angle here. Now, if this angle is in degrees, it's kind of difficult to figure out what this length S is. However, if our angle is measured in radians, or we convert our angle to radians, then it's related to the radius. And if it's related to the radius, that means the angle is proportional to the radius. So theta equals S over R. But this is in radians. Now you can't do this with degrees. So if that's the case, remember that when this thing turns R length, when this is R, there's 3.141 going on of these in 180 degrees. When this thing but turns just S equals R, so if S equals R, then theta equals R over R equals 1, or 1 radian. Well, we could do this the other way. If that proportion works, we can do this the other way. We could say our arc length S, we can use algebra here, equals R times theta. So now if we know what our angle is in radians, we could calculate this. For example, so what is the arc length on a circle of radius 5 if the angle turned is 30 degrees? So now we're looking at the radius here is 5 and this angle is 30 degrees. Well, if we're going to use our arc length formula, S equals R times theta, we can't just directly put 30 degrees in here. We've got to convert 30 degrees into radians. So we either have to use this formula. We'll put 30 degrees in here, and the number of radians then is 30 divided by 180, or pi over 6. Or we can look at our chart here and recognize that 30 degrees is pi over 6. And this is, if you're going to memorize something in mathematics, this is a good chart to memorize, the relationship between degrees and radians. So pi over 6 could save you lots of time in situations. So step 1, 30 degrees equals pi over 6 radians. And you can always remember that because there are 6 30 degrees and 180 degrees, so it's a sixth of that. So pi over 6 radians. That's one way, that's how I kind of remember it. So then we solve this. So S equals the radius, which was 5 up there, 5 times pi over 6 equals 5/6 pi, which is approximately, now you can leave this just like this, that's an exact result. But if you're going to estimate it and calculate it using the calculator, then this is approximately 2.62. If the radius was 5, then the arc length, if we spin 30 degrees, is 2.62. So if it's 5 inches, that's 2.62 inches. Let's just put this in inches, so we'll have some units here. Inches and inches here. So you see, radians are useful because we can proportion them to how far an angle has turned from the initial ray to the terminus, and then we can apply that directly in a mathematical relationship, unlike degrees. And that's, I think, I'm all I'm going to say here.